Hi everyone and welcome. Good to see you all again here. Note, okay, so we're going to start with a relatively straightforward starter problem here. I've got a picture and I've got some, what appears to be two triangles that share a side BC, and I've labeled some of the angles for you. So you want to label the lengths of the 5 segments in order from greatest to least. Now, unfortunately in this picture here, I kind of didn't draw this properly here. So, as you can see, this is clearly not an 85-degree angle. This is clearly not a 20-degree angle and so on. But if I were to draw this, I'd like we want to determine here what the sequence is going to be like. And I think that's pretty fair. So again, consider this here, kind of keep this in mind. And let's start putting things together. Okay, so, it's pretty clear that the first thing to do is, there are some triangles, so we can probably fill in all the missing angles here. So let's see, we have an 80 and a 40 here, that is 120, so 120 from 180 gives me 60. So I think we have a 60-degree angle up here. We have an 85 and 20 makes 105. 105 from 180 gives us 75 here, so that gives us 75 like this. Okay, now, I'm not exactly sure how to put all 5 of them together yet, but at the very least, we can start things off. We've got 2 triangles here, so we can look at each triangle one at a time. So let me limit the triangles 1 and 2 here. So in triangle 1 here, if we just ignore the other pieces and just focus on triangle 1 here, we can ignore this triangle and see, wait a minute, I got 80, 60, and 30, 80, 60, and 40 here, so we can now arrange them in order from greatest to least because of the way a single triangle works here, right? We can go ahead and do that. So that means the side opposite the 80 here, as you can see, is going to be the longest side, so it's going to be BC. And then the side opposite 60 is going to be AC here. And then the side opposite 40 is going to be AB here. So we have this sort of thing like so, right? So I think you can see here, and this for something like this, for triangle 1, it looks something like that here. I guess I'll do that in case. All right, let's try now. Let's look at the next one. So triangle 2. Triangle 2 up here, we can see this. Okay, so again, we can follow the same sort of technique here. We have 85, that's the biggest angle in the triangle, so the side opposite is the longest side, so we have DC. 75 is this middle angle, so it's going to be opposite the next side, BD. And finally, 20 is the small angle here, so that means it's going to have BC like this. Okay, so again, note that we have these individual chains, but the idea was to put all 5 of these objects in a chain. Well, the nice part about this, I think you can take a look at this here. We see that BC here, this entire thing here, this BC is in common, and notice it's at the start of one chain and the end of the other. So it's pretty clear here we can take these 2 chains and glue them together like so. So we can kind of do something like this here, and therefore we can say DC is the biggest, then BD, then BC here. And since everything is smaller than BC in the first chain, we can mention that as well. So now I have something that looks like this here, right? DC is greater than BD is greater than BC is greater than AC is greater than AB here, okay? Now, note that this worked out because the one piece in common, the overlapping side here, was the largest side of one triangle and the small side in the other, and that was because of the angles that we set up here. If we started switching the numbers around, so that instead of a 20 here, let's say I put a 75 there instead of a 20, then things start to mess up, right? We start to our chains don't mesh as well together. So we have to be kind of careful about what's going on here. So the chains worked out really, really well together here because we had this sort of linking like this. There may be situations where the chains don't link like this, but you can still kind of draw partial conclusions from that here, and that's something we'll take a look at that later on, okay?